Okay, guys, so we are going to start because I don't know what happened with the other speaker. Um, let's welcome again to this webinar. Thank you to be here and thank you especially for Dimitra to be here as a speaker. It's a pleasure for me to host you on this webinar of the month of March that will be focused mainly in industrial symbiosis, but in the topic of energy. As you could see here, the other speaker is or will be Aleksandar Anastasovski, apart from Dimitra Spanoudaki. And before starting and giving the floor to them for their presentation, I would like to make you an outline of today. We are going to, or it was supposed that we are going to start with the presentation of Aleksandar about batch processes stream as an obstacle for efficiency, hated chain between production system and industrial symbiosis. And later on, there will be a presentation of Dimitra about enhancing industrial symbiosis through second life batteries. As you know, and you have already used, for example, Lara, we have this question and answer box in the below your screen. You could ask whatever you consider to the speaker about their presentation or about the related topic, so they will be answered to you at the end of the presentation. Let's go for the biography or the bio of each of the speaker. For the first one, it was supposed to be Aleksandar Anastasovski, that is from Skopje. He is graduated in the Faculty of Technology and Metallurgy. He is a Bachelor of Applied Science for CAD software in production processes as well, and he has a lot of experience in energy efficiency, heat integration, and PINS technology for the production processes. From the other side, we have Dimitra Spanoudaki. She's a trained in electrochemistry with experience in battery, electrometallurgy, and corrosion. She's currently a research engineer at Sunlight Energy Storage System Group, and she's focused the moment in innovative energy storage solutions. She's passionate about sustainability, material science, and also about all the batteries technology to try to boost a greener future, as she will explain in a couple of minutes. So basically, that are the presentation, and I would like to give you the floor, Dimitra, for start.
Thank you, Almudena, and thank you for the invitation to this meeting. So I have to share my screen now. Okay, I found the button. Perfect. So how much time do I have?
Let's say 12 minutes.
Okay, 12 minutes. So when I got the invitation from Almudena about industrial symbiosis and energy, I was thinking, okay, what to present and what my audience is.
Sorry, Dimitra, just a second. Could you do full screen?
It's not full screen?
No.
Oh. 1 minute, please. Can you see my presentation?
Yeah.
Okay. Now, is it in full screen?
No.
No. Okay. Maybe I should do it like that. Is it better?
Yeah. Thank you.
No problem.
But if not, just in the right side of the button that you press for the Zoom, you find this full presentation mode. This
yes, but it doesn't work.
Maybe you have two screens.
No.
Okay. Okay, don't worry, work like this.
Hello,
Okay.
Almudena, can you hear me?
Yeah.
Sorry for delaying. I had problems with internet. Hello, Dimitra, also.
Hello, Alexander.
Don't worry. What we did is to switch off your presentation. So we are going to start with Dimitra, and later on you will follow.
Okay, no problem.
Okay. So when I got the invitation from Almudena, I was thinking, okay, what is my audience? What is their background? What do they want to know about energy and industrial symbiosis? And so I decided to present something that we are working on in Sunlight right now through a European project, Horizon project. And it's about second life batteries, batteries that we take from first life, electric vehicles or industrial vehicles, and we give them a second life as energy storage systems. So we regenerate the value. But before starting talking about batteries, I would like to show you this, to say a story about the Kalundborg in Denmark, that it's the most famous industrial symbiosis network there, where there was a collaboration between a power plant and a pharmaceutical company, and they grew into a system where industries share water, energy, and even stream. So I think that an industry's waste is another industry's or community's gold, and more examples like that should take place in communities all around Europe. So let me give you the concept of second life batteries. You know that electric vehicles are all over the world right now. Actually, with the batteries of the electric vehicles, after some years, let's say after 10 years, I don't know, every vehicle is different, their battery need a change, need to be replaced. So what happens to that kind of batteries, the first life batteries? Do they die? Should go to recycling? And the answer is no. They can be reused, refurbished, and reused in energy storage systems, in stationary energy storage system for commercial or industrial or residential use. So this is a diagram here that shows us the state of health, the health of the battery, and the cycles, how many cycles this battery has done. So here we have the first life till 75 or 80%. This is not true. The most of the electric vehicles go for second life when their health is at 90%. But from this point till the knee, this is the point that we call the knee, there is still a life. After the knee, the degradation becomes increased, and we cannot use them. We have to go. They have to go for recycling. So from here to, let's say, here or here, we can reuse the batteries and take the energy and use them to save energy. So why not to do that? So there are many projects around the world and many new startups, companies that they are trying to do that, to refurbish first life batteries to second life batteries and use them for energy purposes. So why do they matter? Because first of all, there is a huge energy demand actually in the system right now, in the communities, and there are a lot of batteries. In the future, there will be a lot of waste from electric vehicle batteries, and we have to do something for them. So then we have the raw material challenges. The batteries to be built, they need some raw materials like lithium, cobalt, nickel. So the problem with these elements, chemical elements, is that they are in specific countries in the world. For example, the cobalt comes from Congo. So there is a problem and a risk with the supply chains. This is one problem. And then there are some environmental and ethical concerns about the mining procedure in these countries. Then we have the high carbon footprint in production of lithium cells, the carbon dioxide emissions. But we can reduce that carbon footprint by reusing these battery cells. As I said in the beginning, at the end of the life of the battery, we're going to have a crisis. In the next years, we're going to have a battery crisis in the planet, because we will have a lot of batteries and we will not know what to do with them. And why is that? Because we don't have a good sustainable solution for recycling the batteries right now. The recycling of the lithium-ion batteries is very expensive. So we can give some time also to the recycling community. Actually, they are metallurgists, this community, to find ways, sustainable ways to recycle the battery. And also about the industrial symbiosis in the battery industry, used electric vehicle batteries can power energy storage systems, microgrids like in hospitals or related communities, to be used as an industrial backup power. Then we must have a cross-sector collaboration. Battery manufacturers, energy providers, the recyclers should cooperate to extend the battery life cycles, and it will have a big circular economy impact. It will reduce the waste, it will reduce the energy consumption, it will reduce the prices of the energy, and communities, industries, countries, continents that they are going to use circular economy ways of thoughts, then they will win in the future, because they will become more sustainable and independent from other countries. So this is just an image to see where the second life batteries can be used. I'm talking about small applications here, small generators to power small generators, cool fans, small e-bikes, etc., things that we have inside our homes. Help the community, street, park, and public lights. Go to areas that are isolated, like mountainsides, islands. In the future, the Greek islands will be powered by second life batteries. There is also a big program here in Greece, and they will become more sustainable and more independent from the mainland. Also grid stations and industries, inside the industries. But to go for the second life batteries, we have some challenges, some obstacles to bypass. One of them is a business plan. So we cannot develop a new innovation, a new technology in the industry in general, if we don't have a business plan. Because now I'm talking from the side of the industry. So we need a promising business plan for the second life batteries, and this is not easy. So first of all, where are we going to find batteries? Someone would say, okay, there are batteries in Europe, a lot of batteries. No, there is a huge supply chain risk about the batteries. The most of the batteries, electric vehicle batteries in the world, are in the Asia Pacific, and not in Europe, not in America. Actually, the lithium-ion batteries were developed there because these countries, especially China, they don't have access to fossil fuels. So that's why they developed the lithium-ion batteries, and the biggest industries and gigafactories are there. So we have we don't have so many batteries here in Europe. But the market value is huge. It's $9 billion till 2030. And the second life batteries will become an everyday phrase in the energy sector, and how we are going to refurbish them and use them. So first of all, we have to find where are the batteries, and usually they are there in Asia Pacific. Second is what kind of market are we going to use for the second life batteries? In general, there are three types of markets: closed market, intermediary-based market, and open market. These markets are coming from the electric vehicle companies, the vehicle manufacturers. Closed market means that an industry should repurpose their batteries. For example, Sunlight should repurpose its batteries. This is very rare in the industry. The only company that does that, not only for batteries but for vehicles only, is Toyota. But Toyota is a huge battery and vehicle manufacturer. The rest of them are not doing that, including Tesla, for example. So we go for the next base market, the intermediary market, that a third party is coming, take the batteries, and integrates them to second life energy storage system. This is the most possible scenario, and this is how the vehicle market is working. And the last one is the open market. Open market means that anyone can buy a battery from any supplier, Toyota, Peugeot, Sunlight, whatever, and do with them whatever he or she wants. This is very difficult, very, very difficult, because you cannot trust a battery from someone that sells that on the internet, somewhere on the internet. It can be very dangerous. So this one is a no-no. So basically, we have the second business model that says that a third party, a third company will come and buy the batteries and integrate them to energy storage system. And also here are the different uses of a second life battery, like the former image: residential, commercial and industrial, utility, and off-grid. In the business models, the one that wins is the early innovators and the early adopters, but this is a high risk. That's why there are a lot of programs, European programs, that they help you to try the concept of the business model and of the second life batteries, and also other innovations. So a second challenge for us is how to choose, sort, and test the first life batteries, and which is the bottleneck. Okay, this is a second image. This is the process of a battery that comes in the factory and goes out to a second life battery, to an energy storage system. A lot of info must be taken from the battery: who used them, how did they use them, what are the reasons for retirement. For example, in an electric vehicle, there might be an accident, so you cannot use the battery. It's dangerous to use it. After the incoming assessment, then we have the disassembly. you have to take over everything to take it out of the battery. Electronics, cables, enclosures, cooling plate, fasteners. So can you see here a second value stream? It's from the electronic and mechanical waste. Someone can reuse them. So a third party comes here, they can buy them. They can repair them or go or take them to recycling. So here we have another also revenue stream for an industry and for a society or for a community. In the battery industry, we take only the cells. All of them, they can be recycled, disposed, be sold, whatever, or reused and repaired. Then we have the step 3, that we should evaluate again the batteries. We cannot send to someone an energy storage system with untested batteries. We have to test them. We have to be sure that they are very safe for the customer. And we have a lot of techniques. And this is the bottleneck. The testing is taking a lot of days or weeks to do that. And then we sort them, regroup them, and make the energy storage system. So actually, the bottleneck to overcome is the testing. We have three categories of testing. It's the mechanical evaluation, cracks, corrosion, damaged modules. Then it's the electrochemical evaluation. What happened inside the cell? What is the state of health?
Sorry, Dimitra, 2 more minutes, please.
Yes. And then is the safety evaluation. So here we actually damage the battery. And the challenge 3 is the standardization and the regulations. For any innovation to become true, we need the state and some standardization organizations. So in the industry, we have the guidance document. In the standardization committees, we have licenses, certifications, regulations, other standards, etc. This is to protect the economy. And if you have to protect the continent or the country, then you have to go to acts. For example, and why are standards and regulations important? They ensure safety, reliability, and efficiency, provide the clear guidelines for manufacturers what to do, how to refurbish, and then they facilitate market growth by reducing uncertainties and by reducing the bureaucracy. And the key regulatory challenges are the lack of global standards. We don't have global standards because one continent with the other continent, USA with Europe and Europe with China are competitive. They have competitive economies, etc. Safety and performance concerns. We have to know how to which are the risks for the second life batteries, and then they help us with the liability and ownership issues. Okay, I can make a battery in my industry, but the second life battery, who has the liability for the second life battery, if not me, someone else? For example, in Europe, we have the EU battery regulation, and it sets a minimum requirement for a second life battery. In North America, USA, we have the UL 1974, and international, we have the ISO, IEC standards, and they are not yet read. So if I want to sell a battery, a second life battery in North America, I have to take that one, the UL 1974. If I want to sell a battery in Europe, I have to follow the battery regulation. So I'm sorry for taking the time, Almudena. And the key takeaways for this presentation is first, a business plan in whatever we do in energy. From an industrial view, we need a business plan, a sustainable business plan. A second life battery support the circular economy. And this is very very good and very promising, because circular economy plans and business plans will win in the future. They're hard to implement, but in the end, it will be the best. Choosing testing first life batteries is a very complex task, and artificial intelligence-driven diagnostics will help us in the future. We need the regulation standards. Lack of global policies make the safety testing and ownership difficult to follow. My future outlook about the second life batteries, it's that also innovation and the regulations will open this sector, the energy sector, and will help the industrial symbiosis concept. So if you have any questions in the end of this meeting, you're very welcome to ask them. Thank you.
Thank you so much, Dimitra, for your interesting presentation. I see already some questions, so I think the audience is interested to discuss further your topic. Let's give the floor to Aleksandar first, and we will come back for the question. So, as I mentioned in the beginning when you were not here, Aleksandar, what your presentation is about the batch process stream as an obstacle for efficient heat exchange, because it related to your experience and your know-how about energy efficiency, heat integration, and big technology. So I would like to give you the floor. You could start presenting.
Thank you, Almudena. Can you see the share screen?
Yes.
Okay. Okay, I will talk about problems that existing when we want to make industrial in symbiosis when companies are using batch processes in their production. First of all, we need to understand what are batch processes, actually what kind of processes existing in industry. There are continuous processes in which all streams and parameters are constant during the whole time, from the beginning of the production process to the end of the production process. And production process is going for a long time. But there are some production processes that have let's say, a limited period of existing, and they can start in the same day, and they can end in the same day, or they can have duration of few days. But in that time, every stream is not active. There are some streams that are active in certain time of period, some other become active later. So that kind of processes we call batch processes, and combination of batch and continuous processes are semi-continuous processes. So now in this figure we can see the demand of hot and cold utilities in one batch process industry, where we have different need for heating or cooling during the production process. There are some peaks. Those peaks are very big problem when we need supplying a lot of heat or cooling during those peaks in the process. And that is a very big problem when we expect to be supplied by somebody else. So in batch processes, there are many issues faced with, like availability, the time dependence, streams fluctuation, change of mass flow and heat flow, chained malfunctions, quality changeability and heat loss, low flexibility, heat exchangers networks, infrastructure and compatibility issues, heat exchangers, pipes, distance, insulation, sedimentation, etc. and short-term heat storage. So here in this figure, we can see two different companies. The dashed line actually separates company 1 and company 2. And all those colored streams, red colored hot streams and blue colored cold streams, are active in that moment. The black streams or black arrows are not active streams. So we can see that in different periods, in period 1, period 2, period 3, period 4, we have different combination of streams, hot and cold streams, that can exchange heat between those two companies. So we need to find how to integrate all those streams that are active in certain time of period. There are different models for doing that. So there are so-called time average model and time slice model as a basic models for integration of or analysis of batch streams. Time average model is not so reliable because it makes actually transform batch process streams into continuous process streams with dividing of, let's say, heat flow or mass flow with the time of duration of the whole process. It doesn't matter that are those streams appearing or not appearing in certain time of the period. And time slice model, according to myself, it is more reliable because in that model, we divide the time in periods, actually time slices, in which we have certain type of combination of streams that are active. And we are analyze all those active streams in all those parts of the companies that we can integrate. So that combination of streams can be repeatable or non-repeatable. That means during the time, the same combination can be repeated few times, or it can appear once or two times in non-scheduled, let's say, appearing. And they are non-repeatable time slices or non-repeatable streams. As a solution of integration of heat streams between two companies or inside the company, we can use different kind of solutions like graphical solutions or analytical table solutions or common heat creating of common heat exchanger network. So these heat exchange networks depends on many things, what kind of fluids we are using, are those fluids can be mixed or not, and many other parameters. About fluctuation of streams in industrial symbiosis, in batch processes, we have variability in supplying of heat between in certain time, and that means we have no all the time offering the same type of heat. I mean the same quality of heat, temperature, pressure, etc. So there can be also chain caused malfunctions. Chain caused malfunctions are the reason of them are some malfunction in company 1 that cannot supply heat to the other company because of that malfunction. And there are things that can be done about that. Those are control and automation and maintenance and reliability. If we do maintenance and plant maintenance on time, we cannot be faced with this kind of problem. Changes in quality of exchange streams. So if we get, for example, steam or some streams as heat for our company, the quality of the steam or heat can be changed because of, let's say, bad insulation, because of existing corrosive or aggressive chemicals. They can make corrosion of the heat exchangers, can have sedimentation in the heat exchangers, and can change the efficiency of heat transfer in heat exchangers. The flexibility of network in industrial symbiosis. There are many issues related to this. If some company needs to change the capacity of production, it will need to change the supply of heat for that bigger capacity of production. So that means it needs scalability. In some cases, that scalability cannot be applied because of the other company capacity. But if we have planning by both companies, we can plan increasing the capacity and solutions related to the scalability of the systems. Infrastructure and compatibility issues that is related to the compatibility of temperature and pressure, that will be more in the heat storage, and pipeline infrastructure that is needed of connection between companies, and very big issues is distance between those companies when we talk about heat, because there is very easy way to lose that heat. The best solution for batch processes for heat integration between two or more companies is heat storage or heat storage systems. So this kind of systems have also some issues that companies can be faced with that. That is heat loss after longer storage, temperature drop due to storage duration, heat storage limitation. Actually, we need the space to store that heat in some filling material. Also, there is a problem when we make integration between streams, certain streams from company 1 to company 2. Those streams have certain temperature and certain heat flow. So the heat storage can have maximal temperature to be lower than the supply temperature of the stream from company 1. So if we have two or more different streams, we cannot combine only one heat storage. We need two or more different heat storage systems to have good supply of heat at certain temperature. But there is another way how to store that energy, using of cogeneration systems, and for example, organic Rankine cycle and Rankine cycle as the main process. We can convert that heat into electricity. So that electricity can be used in the moment of the generation by companies, or it can be stored in batteries or other storage or other type of storage system. Okay, thank you for your attention. That was the main things for me.
Thank you so much, Aleksandar, for your presentation. Also, it's quite interesting the potential of this heated storage system for companies. For the moment, let's start with the question and answer section, this last part of this today webinar. I have a first question for Dimitra, that is about your presentation. Are we talking also about batteries we use home? If so, can you elaborate more, please, on how these batteries can be used to store energy?
Okay, you are talking about the alkaline batteries, the batteries that we buy, we use them, and then we throw them away. I'm talking about lithium-ion batteries. They are rechargeable batteries, and about batteries that they are in electrical vehicles, like in Tesla, Toyota, industrial forklifts, etc. So let me share my screen. Can you see here the energy storage system?
Yes.
The screen? Okay, perfect. This is an energy storage system. It's a huge. It's like that, okay? We place them in photovoltaic parks with wind turbines in industrial complexes. So what do you see here? These are batteries from electric vehicles from Renault. So they took them out from the electric vehicles, and so here we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 24. 20, from 24 electric vehicles, they took out the batteries and they placed them like that. So by combining them, we can store energy. We put them in big containers like that, and then we put some other components. This is the HVAC system, air conditioning, because inside here the temperature is high. We have the inverter to connect it to the grid, and now we can store energy here, and we can give the energy when the grid needs it. For example, during the summer in the Mediterranean, we know that we have a lot of energy from the sun, and the grid energy and the grid system, because we have a lot of photovoltaic parks, becomes very heavy, and there is the risk for a blackout. We need to store that energy and reuse it maybe later during the night, usually during the night. So we built that kind of batteries. We name them energy storage systems, stationary, and battery energy storage system, because there are other kind of energy storage systems like the one that Aleksandar presented. This is fabricated by big batteries from electric vehicles. And this one are from Nissan Leaf batteries, this example. I hope that I answered the question. Although at home, we also use lithium batteries, such as those used in mobiles. Yes, you are right, but lithium-ion batteries are very dangerous batteries. They can catch fire. They can yeah, we know they catch fire. And because why do they catch fire? Because they have a very complex chemistry, very complex chemistry, and to control the chemistry, we use a lot of electronics. So if you are not an electronic engineer to make the PCBs, printed circuit boards, if you are not a software engineer to write the code and make them and make them work, then you cannot do this at home. You have to send them to a recycling company or repurposing company and do that job for you. Thank you, Aham.
Thank you, Dimitra, for your explanation. I have a question for Aleksandar. Dimitra had mentioned these 3 certification or standard, the ISO, and so on. For your case, you had mentioned, for example, about the challenges, this infrastructure and compatibility issues. But there is also any kind of challenges on the sense of standardization, regulation, and so on?
Well, there can be issues in standardization. Practically, there is no problems in standardization in technical way, because you know, there are standard type of pipes, heat exchangers, etc. But maybe there will be more problem in standardization of product that is shared with other company. The standardization of the quality of the, for example, in this case with heat. if you need steam with certain type of characteristics, temperature and pressure, that must be supplied by the other company that is supplying that steam. If that is not the case, the company that is receiving or demanding that steam can have problem in their own process, and that can make problems in, for example, if in the food production or biotechnology, you need to make a sterilization with, for example, 2 atmospheres and 121 degrees of Celsius. If you have no that conditions, practically the whole production can be, let's say, in danger because of bacterial infections and other microorganisms.
Okay, thank you. Thank you for the
Welcome.
explanation. Anyway, for all this kind of issues, we have also to take into account the security. Okay, guys, I don't see more question on the boxes, so I think that we could almost close our section of today, our webinar. I would like to thank you again to Aleksandar and Dimitra for the explanations, the presentation, and all the data that both of you have provided that are really enriching for the action. As always, this section is going to be uploaded in our YouTube channel, and also the presentation will be shared with the audience. So you could find there the emails and the contact of our speakers in case that you have more questions, or you could find any kind of possibility of synergies and cooperation. So once again, thank you all of you for being here, for being present in this webinar, and I wish you a really good weekend. Thank you so much.
Thank you, Almudena. Bye-bye.
Thank you. Goodbye.